Today, IBM and ASTRON announced an initial 5-year joint research collaboration called DOME to develop exascale computer systems for what will become the world's largest radio telescope, the International Square Kilometre Array, or SKA. The SKA will span a surface area over 3,000 kilometres wide, roughly the width of the continental United States. The telescope will be used to explore evolving galaxies, dark matter, and even the very origins of the universe, dating back more than 13 billion years. Albert-Jan Boonstra from ASTRON explains.
The purpose of the Square Kilometre Array is to do astronomical science. With the current generation of radio telescopes, the astronomers can look at the universe and look at the early phases of the universe, galactic research and transient research, all kind of very interesting research areas. With the SKA, the astronomers can do even better than that. The technology advances, and with the SKA we will have a telescope which is about 2 orders of magnitude more sensitive than the current generation of radio telescopes. With this telescope we can do unprecedented science. We can look back at the early phases of the universe, for instance, in the era in which the first stars were being born. So with the SKA, that will be the first telescope able to map that era in great detail.
Try to imagine all of the daily traffic on the World Wide Web and double it, roughly 1 exabyte. That's how much data the millions of antennas will produce each day. The technology to handle this is beyond current state of the art, which is why ASTRON turned to IBM experts in the Netherlands and Zurich. IBM scientist Ton Engbersen explains.
Exascale computing is really about lots and lots of PCs. Right? When you think of today's PCs, then we'll probably get 100 million. And that is also a problem, right? Because think of the amount of power which 100 million PCs today would dissipate. And then when we think of this type of projects where we have so much data to work at, then we cannot do that with the technology which has today's PCs. So we have to think very carefully over how to do this at absolutely low power. And that is, then you get into exascale. Very high I/O rates, lots of data, get that data fast to the computers at low power. And that is very exciting. We have never done something like that. Plus the fact that, look at this, every business in the future will likely have a lot of data which they have to match with data from the outside. And that is what we are preparing. This is very relevant to business too.
To break this challenge into manageable parts, the scientists are investigating several areas from 3D chip stacking to photonics to storage technologies. Martin Schmatz, who leads the technical team at IBM, explains.
Everything is about the big data that is generated by the antenna. Big in that context means exabytes of data each and every day. That's comparable to the amount of data that is created on the entire internet in the same period of time. So we have to transport that data, compute that data, and store the data. And last but not least, also have to have a rigid system design to have all these components work nicely together. For the transportation of the data, we will leverage optical principles. We have a decade of experience in optical communication. For computing, we will leverage not only our vast experience in simulation of systems with tens of thousands of compute nodes, but we also leverage technology, 3D chip stacking and water cooling in order to have a very efficient processing of that data. For storage, we also will leverage new and novel components like phase change memory. And in the system design, it has to be understood that the big data analysis is not only important for astronomers, but more and more important for many industrial applications, like for example in the healthcare.
The collaboration will be based in Drenthe, the Netherlands, at the newly established ASTRON and IBM Centre for Exascale Technology. Albert-Jan Boonstra explains.
The Netherlands is ideal for this collaboration as the Dutch have a long-standing history in astronomy in general, and in radio astronomy, ASTRON is one of the leading parties in the SKA consortium, which leads towards the SKA. So the Netherlands, and together with IBM, is a good team.
The SKA is expected to be completed in 2024. By the end of this year, astronomers are expected to choose between Australia and South Africa as its location. This is Anne-Marie Cromat reporting.